Then the girl in the corner with the scarlet letter. While you're watching, you may think that she doesn't matter, but no one knows you better.
Hi guys, I'm Jubel Laria and I'm here to give you the summary of Chapter 8, which is Subnetting IP Network. So in Subnetting IP Network, we have designing and implementing and managing an effective IP addressing plan ensure that the networks can operate effectively and efficiently. So understanding the structure of the IP address, to how to modify the hierarchy in order to efficiently meeting routing requirements is an important of planning an IP addressing scheme. So the IP address have two levels, a network and a host. These two levels of addressing allow for basic groupings that facilitate in routing packets to the destination network. Next is the broadcast domain. So the broadcast domain locate in other devices and the services. The other devices which is send layer to broadcast to IPv4 address on the local network to discover the MAC address. Next is the services which is using the dynamic host configuration protocol to send broadcast on local network to locate in server. For example, when a switch configure, if a switch in configure which to receive broadcast, it would forward it. Next is the problem with large broadcast domain. So a problem with a large broadcast domain is this host can generate excessive broadcast and negatively affect network. The slow network operations due to the significant amount of the traffic, it can use the slow device must accept the process and broadcast packet. The solution to reduce the size of the network is to create a smaller broadcast domains and process and that called subnetting. Next is the reasons of subnetting. The subnetting reduces overall network traffic and improves performance. The subnets are allowed or not allowed to communicate together. Next is the network administration can group devices and services into subnet that determined. So in this chapter, it describes how subnetting is performed, understanding how to subnet can work, and this chapter focus on looking the binary and the method. Next is the octet boundaries. So the octet boundaries are used to identify the specific broadcast domain. To recall the prefix, length, and subnet mask. The IPv4 subnet is using by one or more hosts or bits of a network. So this is done by extending the subnet mask to borrow some of the bits from the portion to address to create the host to additional the bits. The network is the octet boundary of 8, 16, and 24. The subnet masks and the network and the host bits are the number of hosts each subnet can connect. Next is the subnetting on the octet boundary. The network addresses can connect 16.772.1.4 hosts in the broadcast domain. And this would provide the interface the ability to define up to 256 subnets. And it considers the following boundary can be useful. So it is popular in subnetting because it recommends a reasonable number of the hosts and conventionally subnet of the octet boundary. Next is the class subnetting. So the class subnetting as borrows host bits common from 8, 16, 24. So the network addresses to a smaller number of end devices. In 25 row, it borrowing the fourth octet creates 2 and supporting 126 of the host, and the 26 is its borrow subnetting 4 and the host 62. And 27, there are borrowing 3 bits and creates 8 subnetting and the host 30, and 28, it borrowing 4 bits and 16 subnetting and the 14 host, and the 29, it borrow the subnets in the 6 hosts, and the 30 is the 64 subnet and the 2 hosts. Next is the class subnetting example. So, to understand how subnetting classes level can be useful, the subnet, the private network address, the 3 octets played in the decimal, while the last octet played in the binary. So the subnet mask is 255, indicated of 255, and the 24 prefix length. So the LAN interface providing 254 host IPv4 address, and the 2 subnettings are derived from changing the value of the bit borrowed, either 0 or 1. So in the subnet mask for the both networks, it displayed the resulting subnetting mask. It indicates that the bits is now part of the network portion. In the 2 subnetted address in their common subnet mask is 1 bit that is borrowed from the subnet mask for each subnet. So the creating 2 subnets is the gigabyte interface. Each LAN is assigned of the subnets. The IPv4 address is 192.168.1.0 and it contains 0 bits on all the portion of the address. The first IPv4 host is 192.168.1.1 and it contains 0 bit plus the rightmost bit 1 bit in the host portion of the address. The last IPv4 host address is 192.168.1.26. It contains 1 bit plus rightmost 0 in the host portion of the address. The IPv4 broadcast address is 192.168.1.27. It contains all 1 bits in the host portion of the address. So the router interface must be assigned an IP address with the valid host range of the design subnet. The respective subnets using the IP address interface configuration command. So the host on each subnet can be configured the IPv4 address and default gateway. Next is the subnetting formulas. The subnets that can be created from the bits borrowed use the formula displayed in the figure 1. So to calculate the number of the hosts can be supported, use the formula displayed in the. There are 2 subnetting addresses that cannot be assigned to a host network of the addresses and the 7 host bits remaining. So the calculation is. This means that each of the subnet has valid host addresses. Next is the creating for subnet is the range of requires 3 subnets borrowing the single bit. Only provide 2 subnets. So to calculate the number of the hosts, the last octet after borrowing 2 bits, the subnet, there are 6 hosts in the remaining. Apply the host of the calculation formula to show the reveal of the subnet can support 62 host addresses. Next is the creating subnet with a 16 prefix. So in 16 bits in networking portion, the 16 bits in the host portion is the available to borrow the creating subnet in the table highest possible scenarios of 16 prefix. So the reason it is big is because the 8 additional bits that can be borrowed the number of the subnet hosts are simply larger. Next is the creating 100 subnet with a 16 network. So it chosen the private address 172.16.0.0.16 in the internal network. So when borrowing bits from 16 address, start borrowing to the octet going from the left to right. Borrow a single bit at time until the number bits necessary to create 100 subnet and reach. To the subnet mask change to reflect the borrowed bits. When 7 bits borrowed, the mask is extended 7 bits into the third octet. The decimal represent 255.255.254.0 prefix because the third octet is 1110 in the binary and the fourth octet is 000 in the binary. Next is the calculating host to examine the third and fourth octet after borrowing 7 bits. The subnet is the bit remaining in the third octet and the 8 bits remaining in the fourth octet. The total 9 bits that we are not borrowed. Next is the creating 1000 subnets with a 8 network is the network addresses 10.0.0 as default subnet mask of 255.2 of 255.00 or 8. So the larger the enterprise may need even the more subnet, and each client will need to plenty of the space of those portion on their own subnets. Next is the subnet based on the host requirements. So there are two consideration when planning subnet: the number of the host address required for each network, the number of the individual subnet needed. So the more bits borrowed to create subnet, the fewer host bits available. If more host addresses are needed, more host bits are required, resulting in fewer subnets. And recall that two of the addresses cannot be used, so the usable number of the addresses can be calculated as 2 raised to n minus 2. So the subnetting based on the network requirements is to, this may be the case of these organizations choose to separate their network traffic based on the internal structure. So you choose to put all the host devices used by the employees in the engineering department in the network and all hosts used by the management in separate network. And the more the bits borrowed to create the additional subnet means fewer available hosts per subnets. Next, the network requirement example is the addressing sim would allow for growth in the both number hosts per subnet and the total number of subnets. And it determined the subnets result in 16 subnets because the example internet network requires 9 subnets. This will meet required the allow for the some additional growth. So that's all guys, the summary of chapter 8.